As in the last examples, different samples may get different results. Knowing the purpose of the sampling is very important. If the sample size is too small, if it is not randomized, or if the method of obtaining samples is not well thought out, you will get biased results. Bias comes from how a question is asked as well as who is being asked. Surveys or statistics that are biased do not return valid results. One kind of biased sample is a convenience sample, which is made up of people who are easily accessed. For example, if a survey question is about building a new indoor sports facility in a city, and only people using an old indoor sports facility are surveyed, the responses may not represent the opinion of the entire city. Another kind of biased sample is a voluntary sample, which is made up of people who want to respond to the survey. For example, if a survey question appears at the bottom of a receipt, the only people who respond are those who care enough to tear off the survey from the bottom of their receipt and mail it in. The responses from this sample may not represent the opinion of all the store's customers. It's important for questions or surveys to be unbiased. That way, the results mean something. Here are some more types of bias in sampling. Selection bias is a method that excludes some part of the population from the selection process who systematically differ from those that are included. Some examples include call-in polls on TV and phone surveys. Another bias that exists is response bias. This method of observation tends to produce measurements that differ from the true value of the response. Some examples include, but are not limited to, using a scale that has not been calibrated, untrained technician that is working the tool being used, the wording of a survey, and interviewer influence. The last type of sampling bias is called non-response bias. This occurs when data is not obtained from all individuals in the sample. In other words, when those who respond systematically differ from those who do not respond. Examples include a telephone survey, because not everyone will necessarily pick up their phone, and mail surveys. Not everyone will mail back the survey. So that's why it's considered to be biased. It is very important to remember that a biased sample will always be biased. It doesn't matter how much data is collected, it will not fix it because the data will always be collected in a biased fashion. A biased sample does contain some information about a population, but you must be cautious of the interpretation. For sampling to be unbiased, it should be randomly chosen from a population. Random samples are just that, they're random. They are used frequently because they tend to represent the population chosen, since randomization does not systemize some participants over others. Random sampling can be done in a couple of different ways. The first way is with replacement. This is when an individual can be selected more than one time to be in a sample. This can occur because the individual, once selected, is placed back into the population. This method needs to be used when the sample size, n, is more than 5% of the population size. In other words, 20 times lowercase n has to be greater than the population size, capital N, which is equivalent to the sample size has to be greater than 5% of the population size, 0.05 times the population size. And then without replacement, an individual is selected and cannot be selected again, and they are not placed back into the population. So I can't select the same person more than once. The sample consists of n distinct individuals, and this method is used when the population size is infinite and the sample size n is no more than 5% of the population size. In other words, 20 times the sample size must be less than or equal to the population size, which is equivalent to the sample size being less than or equal to 5% or 5/100ths of the population size. And the without replacement is the most commonly used method. There are several different types of random samples that can be chosen from, depending on the experiment or study. The first one is a simple random sample, or SRS for short. In this case, each possible sample size, n, has an equal chance of being selected from the population, capital N. In a stratified random sample, the population is divided into non-overlapping parts called strata. That's where the strata from the beginning of stratified comes from. And a smaller, simple random sample is selected from each part. So, for example, a survey could be given to 5 random students in each homeroom. The fact that they're using a homeroom separates the population into smaller, non-overlapping parts, and then 5 random students are chosen from each one. Systematic random sample is when the surveyed population is selected according to an interval of time or to an item interval. So a survey could be given to every 10th student who enters the building. There's a system involved. There's a set number that they always abide by in order to select the next person. That's a way to remember what systematic is. Another one is called a cluster sample. This is if the population naturally consists of heterogeneous, non-overlapping groups or clusters. Then a simple random sample of clusters can be drawn, which creates this sample. So for example, selecting 5 seniors from each neighboring high school would be a cluster sample. A census is another type of sampling method. It is different from the others because it selects all the items or subjects within a population. If you think about our population census that happens every 10 years, we all receive a form that needs to be filled out. So it goes to everyone within the population. Once a sampling method has been well thought out and proven to not be biased, one must consider the sample size. As a rule, small sample sizes will result in a large variation, while larger sample sizes result in less variation. Let's try an example. You are a quality control manager at an ice cream factory. Out of the 4,000 gallons of ice cream they produce in one day, you choose 4 of those gallons to pull off of the lines to check for quality. Is this enough? And if so, explain why it is sufficient, and if not, determine a range of values that would be sufficient. Well, if we take a look at this, the problem is saying that 4 out of 4,000 gallons of ice cream are being checked, or 1 out of 1,000 when it reduces. And that's also equivalent to being 0.1%. Or 1,000th. Is this considered to be enough? The answer here is no, it's not considered to be enough because it's such a very small portion of the sample that is being inspected. So sample size is too small. And also, if not, determine a range of values that would be sufficient. Well, this could vary. We could make it, instead of being 4 out of every 4,000, we could make it be 4 out of every 400, or 1 out of every 100. That would be 1%. And if you wanted it to be more accurate, you could say 2 out of every 100. Or 2% that come off the line get inspected. And here is also a solution worked out for this problem. It does agree with what we said. No, the 4 out of every 4,000 or 1 out of every 1,000 is not enough, not sufficient. And the answers can vary based on the interpretation of sufficient. We could end up having, for every 100 gallons, 2 of them are checked for quality. That's a sample answer.